Types of radiation. There are three types of radioactive radiation might be released from a nucleus during a radioactive decay, and there are alpha radiation, beta radiations, and gamma radiation. Now for this radiation, we need to know a few things about it. First, we need to know the charge of the radiation. And second, we need to know the comparison of the mass. Which one has the greatest mass, which one has a lower mass, and which one has no mass. Okay. And the third one is the penetrating power. We need to know their penetrating power. So alpha has a charge of positive 2. Okay, this is a relative charge, positive 2. Proton has a charge of positive 1, relative charge positive 1, and electron has relative charge of negative 1. Alpha radiation has a charge of positive 2, relative charge of positive 2, and its mass is 4 atomic mass unit. This U is the unit for atomic mass unit. The mass of one proton is 1 atomic mass unit, and so does the mass of one neutron. So the mass of alpha radiation is 4 times of the mass of a proton, or 4 times of the mass of a neutron. You don't need to really remember the mass, but you need to remember the comparison of the mass, and which one has the greatest mass, which one has the lowest mass, and which one has no mass. Okay, and the penetrating power. The alpha radiation has a range in air for a few centimeters, which is very short. Okay, in air, the obstacles is very low. Okay, but it can only move a few centimeters, means that its penetrating power is very low, and it can be stopped by a thick sheet of paper. Means it can be just stopped by a piece of paper. So the penetrating power is very low. Beta, the charge is negative 1. Just now, alpha, the charge is positive 2. Alpha has positive charge, beta has negative charge, and the mass is 1/1820 atomic mass unit. So alpha has 4 atomic mass unit, but beta only has 1/1820 atomic mass unit. It means that the mass of a beta is very, very low when compared to the mass of alpha. So alpha has a big mass, and the beta has a very low mass. The penetrating power of beta is higher than alpha, and it can be stopped by a few millimeters of perspex or aluminium. So penetrating power is moderate. Yeah, it can easily pass through air, but it can be stopped by a few millimeters of aluminium. How about gamma? Gamma has no charge. Okay, no charge, no mass. Yeah, means that it's not particles. It's a wave. It's an electromagnetic wave. Okay, no charge, no mass, and the penetrating power is very high, most penetrating, and it can't be stopped by anything, but their intensity is greatly reduced by several centimeters of light. Okay, and this gamma is often emitted at the same time with alpha and beta particles. Okay, so a radiation can radiate more than one type of radiations. So a nucleus, when it experiences a decay, it can emit more than one types of radiations. Okay, sometimes it's alpha and gamma, sometimes it's beta and gamma. Okay, so this is the comparisons of alpha, betas, and gamma, and we have this diagram to help us to compare the penetrating power. So this is a piece of paper. Alpha will be blocked by this piece of paper. Okay, and beta and gamma can pass through the paper, and beta radiations will be stopped by 5 mm aluminium. Okay, but gamma can easily penetrate through this 5 mm aluminium. Gamma can be greatly reduced. Okay, not 100% blocked, but it can greatly be reduced by 25 mm of lead. Okay, so never fully absorbed, but can be reduced to half by a 25 mm lead. So means alpha has very low penetrating power, gamma has very high penetrating power, and the penetrating power of beta is moderate. Okay, deflections by electric field. Now this is related to its charge. Okay, so let's say we have a negative plate and a positive plate that create an electric field. Okay, so the alpha carry positive charge, it will be deflected towards the negative plate. Okay, positive will be attracted to the negative plate. Beta has negative charge, it will be attracted to the positive plate. And gamma is neutral, so it will not be deflected by the electric field. Okay, so you must know this. Alpha carry positive charge, it will move to the negative plate. Beta carry negative charge, it will move to the positive plate. Gamma not deflected because it's neutral. Okay. So this is a summary. The charge of alpha is positive 2, and beta is negative 1, gamma is neutral, and this is the penetrating power. Okay, alpha can be absorbed by a sheet of paper, beta can be absorbed by a 5 mm aluminum, and gamma never fully absorbed but can be reduced to half of the intensity by a 25 mm of lead. Since alpha and beta carry charge, it can be deflected. Alpha will be deflected towards the negative plate, beta towards the positive plate, and gamma is not deflected. Okay, so this is what you need to know about the three types of radiation, alpha, beta, gamma.